Alright, welcome to 1.6 Absolute Value Equations and Inequalities. Our essential question today, how do you write and solve equations and inequalities involving absolute value? So now we're extending our knowledge of inequalities and we're going to add on absolute values to them. This is day one. We're going to do 2 days worth of this. So here we go. So the absolute value is the distance from 0 on the number line. So for example, it's basically asking how far from 0 is 3. If you plot your point, it's 1, 2, 3. So the absolute value of 3 is 3. Okay, now what about negative 3? How far from 0 is it? 1, 2, 3. So negative 3 is also 3. Okay, so you can kind of keep going with that. The absolute value of negative 5 is just 5. The absolute value of 5 is 5 as well. Okay, so when we solve the equations for the variables, what we're going to do is we are going to have to play both scenarios. So what I mean by that is that in order to get an answer of 5, our x could either be negative 5 or positive 5. And so we have to make sure to include both solutions, because they both may work. Okay, now for this one, same thing with this one, right? X could either equal 2 or negative 2. Or negative 2. Okay. Now, is this one possible? Can you have an absolute value equal a negative number? And the answer is no. You can't. No solutions. Because absolute value, the answer will always be positive. Okay? The next one here. So we're going to kind of move on to solving something a little bit more complicated. What's the solution of absolute value 2x plus 5 and it's going to equal 9? We're going to graph the solution after we get done. So first off, what we need to remember is that we're going to drop, how we solve these things, we're going to drop the absolute value signs. So we're going to do 2x plus 5 equals 9. Okay? Or, and this is how you solve absolute value, you have to treat it like an or equation. Or we're going to do 2x plus 5, because we have to account for the fact that you could get a negative number in here, right? Like this right here could be negative and it's still going to work out, right? And so we're going to go 2x plus 5 equals negative 9. Now, yes, I acknowledge I just said absolute values cannot result in a negative number. I get that. But for this case, we need to have positive answer and negative answer so that we can play both scenarios for within the absolute value signs. Okay, we're not calling this, don't confuse it with what I said right here. It's a different thing. Okay, so now we just solve both sides. 2x, we subtract the 5 and we get 4, and we divide by 2 and we get 2. So that's one situation. Now over here we subtract the 5 and we get 2x equals negative 14. And we divide by 2, we get x equals negative 7. Okay, now we have to check. Okay, this is very important. You have to check both of these answers because maybe they won't work. We'll see. Okay, so for this one, the absolute value of 2 times 2 plus 5, does it equal 9? So we got what? 4 plus 5, it does equal 9. That's a check, so 2 works. And then we're going to do 2 times negative 7 plus 5. Does that equal 9? Let's see, 2 times negative 7 is negative 14. Oh, I'm sorry, guys. Oh no, yeah, okay, we'll keep going. Sorry. 2 times, it's early in the morning. Here we go. 2 times negative 7 is negative 14, plus 5 is negative 9. So I'm just going to keep going with my equation. So we have absolute value of negative 9. Does that equal 9? Yes, it does. So they both work out. Okay, now we're told to graph it. Graphing is actually going to be really easy because we have an equal sign. Okay, so it has to be those numbers. Like, it can't be any other numbers. It's just those ones. Okay, so we'll go with maybe, since we're going down to -7, we'll put 0 here, +2, we'll just go by 2's, -2, -4, -6, -8. Okay, so our solutions are 2, so we put a dot at 2, and -7, which would be right about here. Okay, and then what I was talking about with our need to check is that we might have an extraneous situation, extraneous solution. Okay, and that's essentially a value that it appears to be the solution. So when you get done solving, you're like, okay, I got 2 answers. But then you go to plug it back in and it actually doesn't work. And you'll come across some of these. And so it's very important to always check your answer because you might have an extraneous one. Okay. So here we go. Remember, we're going to treat it like an OR problem. So 2x minus 1 equals 5, or 2x minus 1 equals -5. Okay, so we add 1, we get 2x equals 6. We divide by 2, we get x equals 3. And then over here, or 2x, when we add 1, we're going to get 4, -4. I apologize, -4. And then we divide by 2, and we get -2. Okay, so far it seems like everything's going well. Now let's check and make sure they both work. So absolute value of 2 times 3. Minus 1. Does it equal 5? That's our question. Okay, so 2 times 3 is 6. Minus 1 is 5. So the absolute value of 5 equals 5. Yes, it does. Cool, that's a check. Okay, now we check this one. Absolute value of 2 times -2 minus 1. Does it equal 5? Okay, so let's see. 2 times -2 is -4. -4 minus 1 is -5. And yes, it does. The absolute value of -5 is 5. So that works out. And we are going to graph it here really quick. So we got our answers of -2 and 3. So we'll just put 0 right here. 1, 2, 3. 1, 2. So we got a dot right here, and we got a dot right here at 3 and -2. All right, for this one, a little bit more complex. Now we have stuff outside of the absolute value symbol. And before we go to solve this, we need to move all of the extra stuff over to the other side. So we're just left with the absolute value. So the first thing we're going to do is we are going to add 1. We're going in reverse order. So we'll add 1 to both sides. We end up with 3 absolute value of x plus 2 equals 9. Okay, now we're multiplying here, so we need to divide by 3. We're left with absolute value of x plus 2 equals 3. Okay, and now this is a little bit more familiar. We can work with this one, right? And so what we're going to do, I'll change colors here. We're going to do x plus 2 equals 3, or x plus 2 equals -3. And we solve these, so we get x, when we subtract 2, we get x equals 1. We subtract 2 from here, we get x equals -5. Okay, so those are our solutions so far. Let's check them. Okay, so when we go to check, we're going to plug it back into the original equation. Okay, so we got 3 absolute value of 1 plus 2 minus 1 equals 8. Okay, we do the stuff in absolute values first. Treat absolute values like parentheses as you are in your PEMDAS stuff. That kind of falls in with the parentheses category. Okay, and then we multiply. So, well, the absolute value of 3 is 3, right? So 3 times 3 minus 1. So we got 9 minus 1, which is 8. 8 equals 8. So 1 checks out. Now let's check -5. So we got 3. Oh, absolute value. -5 plus 2 Absolute value minus 1. Does it equal 8? That's our question. Again, take care of the absolute value stuff first. And so we get absolute value of negative 3 minus 1 equals 8. And absolute value of 3 is 3, so 3 times 3 minus 1. So again, we get 8 equals 8. So we haven't come across any extraneous solutions so far, and that's probably a good thing, you know. But we need to keep checking just to make sure. All right, now this one, you might look at it and go, oh my goodness. But I think we can do it. Okay. So again, take care of the extra stuff first. We're going to add 2 to both sides. So you get plus 7. And so we get, we get plus 2. So we get 7 on this side. And then absolute value of 3x minus 6 and negative 1/3. Now, dividing by negative 1/3 is the same as multiplying by negative 3. That cancels itself out here. We multiply also by negative 3 over here, and we get absolute value of 3x minus 6 equals negative 21. Okay, and now we play our scenarios here. 3x minus 6 equals negative 21. Or we could do 3x minus 6 is positive 21, right? We're switching the sign. So we add 6 and we get negative 15. We divide by 3 and we get negative 5, so that's one of our answers. Okay, over here, positive 21 this time around. When we add 6, we get 27. There's 3x. And so then we know that x equals 9. 27 divided by 3 is 9. Okay, now we go to check them. And we plug them into the original equation. And I'm running a little bit low on time, so I'm just going to tell you that negative 5 is extraneous. I did all the work. I checked my answer. Feel free to pause the video, but negative 5 does not work at the end. Okay, well, let's check the other one. And come to find out, 9 is extraneous as well. So, again, pause the video if you want to see the work and copy it down into your notes and check yourself. But there we go. All right. Now, this last one, I don't think we're going to have time for. But it's largely the same way of solving it. Just remember when you do your OR statements, so you just do 3x plus 2 equals, now usually it's just the regular one, 4x plus 5, or our other one would be 3x plus 2 negative, now parentheses are important, 4x plus 5. Okay, and then we're going to distribute the negative. So it'll look like this. Okay, so you can go ahead and do the rest of the work yourself. It is just slightly a bit of a long problem, but I really do encourage you to go through it. It might appear later on in the year, you know, like on a test or a quiz or something like that. So it is important. If you have questions on it, ask me. We just ran out of time on this video. So that was day 1 of 1.6.